All right, so here's a quick tutorial video kind of talking about recovering the function from its derivative. And the way I'm going to do that is, in this example, I'm going to sketch the function. This thing that's given here, we're going to assume that this is the derivative of a function. Maybe I'll call it g prime of x. And what we're going to be asked to do is, maybe down on the bottom here, sketch g of x. And just parenthetically here, I'm going to say assume g of 0 equals 0. It's kind of a minor point. It turns out that there's lots of different functions that have this exact derivative. So in order to not have there be infinitely many solutions to this question right here, or this prompt, I guess, I have to kind of anchor the answer somewhere. And so what I'm saying is anchor it right here. Start right here, figure it all out from there. But before I get to that question, before I try to dive in and sketch this thing, I want to talk about the shapes of graphs kind of more generally, because I think once we get the idea of the different shapes, the 6 different general shapes that a graph can take on, we'll be able to sketch this graph just by looking at this thing right here. So really to get to that, what I want you to know the difference between is these 6 cases that I was talking about. First of all, I want you to know the difference between a function increasing and decreasing. And those are just as they sound. Increasing means going up, decreasing means going down. So as you read this thing from the left to the right, is it going up or is it going down? Turns out that there's more to it than that, as you might have guessed. So yeah, this starts to describe the shape of a graph, whether it's increasing or decreasing, but there's more to it than that. I mean, this right here is increasing, but this right here is also increasing. And these two things look very different. In fact, let me scoot that over a little bit. I can draw you a third one here, like this. 3 different types of increasing. This one's increasing, and it's kind of getting steeper and steeper as I go from left to right. This one's increasing, but it's getting less and less steep. And this one's increasing, it's kind of a straight line. The steepness is staying the same. Those are 3 of the 6 different shapes that we're going to talk about. The other 3 are very similar, except now they're going to be decreasing. So I want that same idea of decreasing, except it could be decreasing like this, could be kind of decreasing like this, or it could be decreasing like this. It's meant to be a straight line. I guess that's pretty straight. It turns out that these 2 types, in order to be able to tell these apart, we need to give them all names. We're going to call these 2, we're going to call them concave up. And I'll explain why we call it concave up. Well, I'll try to in just a second. These next 2, we're going to call them concave down, mainly to differentiate them from concave up. And these are just linear. Seen those before, straight line. Where those names come from, concave up, is, well, I'll get back to that later. I'm just going to leave it at there's these 6 types and these are the names for them. So back to this problem here. If you could tell me somehow that, between -4 and -3 here, my graph should be increasing in concave up, for example. If we knew how to figure that out, then we know between -4 and -3, it should look, roughly speaking, like this. Maybe not exactly like this, but roughly speaking like this. So our goal is to be able to look at this thing and tell which of these 6 types we're in. And the way we do that is by using this information down here. And so what it says is that when you're trying to draw the graph, what we'll be trying to do later, we know that it should be increasing anytime the derivative is positive. If f prime is positive, that means our graph is increasing. Similarly, if f prime is negative, that means our graph is decreasing. So because this thing is the derivative, I'm going to call it g prime instead of f prime. Because this thing is the derivative, if this thing is positive, what that means is that my function must be increasing. So if I look at this thing is positive anytime this is above the x-axis. So specifically from over here all the way out this way, I feel comfortable saying that this thing that I'm trying to draw, g, will be increasing. Similarly, out here from 2 to infinity, it looks like my derivative is positive. So therefore, g will be increasing. And then everywhere in between there, it looks like the derivative is below the x-axis. If the derivative is below the x-axis, if the derivative is negative, if I come back down here, f is decreasing, right? The function is decreasing when the derivative is negative. Okay, so that means in here, I want g to be decreasing. So that starts to tell us how to draw it, but that just tells us whether it's going up or down. It doesn't tell us which of these shapes it takes on. So in order to figure out which of these shapes it takes on, we really need to think about the second derivative. So I need to figure out where this thing g is concave up and concave down. If I could figure that out, since I already know where it's increasing and decreasing, I'd know exactly which of these 6 different shapes it takes on. And so the way I do that is by using these next set of rules. I know that my function is concave up when its second derivative is positive. However, I don't have a picture of its second derivative, I have a picture of its first derivative. Fortunately, there's a way to tie together the second derivative and the first derivative. The second derivative is just the derivative of the first derivative. So what I'm saying is this thing here is the derivative of this thing here. And we just learned above that the function is increasing when its derivative is positive. So since this is the derivative of this is increasing when this is positive. If you can tie that together, you can make the connection that f is concave up when f prime is increasing. And why that's really important is it tells you when the thing that we're going to try to draw for the final answer should be concave up or concave down. It is concave up whenever this thing that's pictured, the derivative, is increasing. So what I do is I go back over here, maybe it's time to switch color, and I say, well, this thing right here is increasing. Well, here's one spot it's increasing from -4 to -3, right? You always read these things left to right. And if you look from left to right in here, it looks like the derivative is increasing. We just said that whenever the derivative is increasing, the graph is concave up. Therefore, I have these 2 different intervals on which I'm concave up. It's increasing here, and then it's increasing here. What about concave down? Well, it's concave down where it's decreasing. We're decreasing out here. So it's concave down, and we're decreasing here. So I got concave down. It turns out that's everything that I need to know to get a rough idea of the shape of this graph. So what I'm saying is that if I label these, maybe we'll call this, I don't know, I up, increasing, concave up. So this would be D up, and this would be I down, and this would be D down, and this would be L for linear. Oh, I did that wrong. No, I did that right. And this would be L for linear, and it's increasing, so maybe I L. And this is decreasing, so D L. Sure. There's 6 names that I just made up for these 6 types. All right, so now what I have to do is combine all this information. Combine the information in red and the information in blue. So let's see, red and blue, purple, if I remember right from back in the day. So I'll draw this in purple. So from this interval from -infinity all the way up to -4, it looks like my function's increasing because red tells me it's increasing, and then it's concave down. So what that means, increasing, concave down, it's taking on this shape right here. And then what happens? Well, we're still increasing. I mean, we're increasing all the way till we get over here. But between here and here, it switches to concave up. So we're increasing and concave up, and then we go back to increasing and concave down. All right, we're increasing all the way from here to here, which is why these all say I, but the concavity switches a little bit. And then we switch to decreasing, and we're decreasing. Well, we decrease till all the way over here, but we're only concave down until right here. So I'm decreasing and concave down here, but then when I get to this point, I switch to concave up. So all the way over to here, I'm still decreasing, but now I'm concave up. And then finally, to finish it off here, it looks like I'm increasing in concave up. So I'm going to take on that shape. So now what I have to do is I have to sketch something. Apparently I'm doing it in red. That goes through this point 0, 0. That follows the shape given on each of these different intervals. You can go left to right, or right to left. It's easier to go left to right. So let's start by going left to right. So I'm going to start out sketching something that's D up. What was D up? I forget what that one looks like. Oh, there it is. This basic shape. It's going to be decreasing and concave up. So what I'm saying is all the way until I get over to 2 here, I want to have this basic shape. How do I know how much to exaggerate it by? How steep should I start out? Well, since this height is -3, the slope of the tangent line at this point should be -3. And since the height here is 0, maybe those are worth labeling down at the bottom. I know that because the height here is 0, let's put a little dot. No, I don't want to make it look like it's on the graph. I'm going to say I want to be flat here and flat here. So just a little note for myself at the bottom of the graph that when I get to that x coordinate, I better make sure it's flat. So again, we're on this interval, this D up interval. So I want to graph something that looks like this. So if I graph something that looks something like that, and then I'm flat by the time that I got to 2, I've just drawn the right shape on here. And then what happens after that? Well, then it changes to increasing and concave up. What does increasing and concave up look like? Well, let's see. There's increasing, there's concave up. It should take on this shape. Fine. Something like that. You might ask, how do I know how steep to draw this? How is this exactly what it looks like? It's all kind of an estimate. You know, we're just sketching an estimate of the graph at this point. So I'm going to call that good. So what I've done is I've drawn the right-hand side of the graph. Now I got to draw the left-hand side of the graph. It's a little bit hard because now I got to think right to left. But if I use my little key up here, it'll help a lot. I want to be decreasing and concave down. Wait, what does that look like? Decreasing, concave down. This shape right here. So from here to here, I want to be decreasing and concave down. It's going to look something like that. Note that at this point, I was supposed to be flat. It's good. It looks like I'm flat at that point right there. Then what happens? Now I have an increasing concave down interval. Increasing concave down looks like this. So I want to draw something that goes like that, roughly speaking. And then from here to here, I want to be increasing concave up. Increasing concave up, this shape right here. It's just between -4 and -3. Fine. There it is. Be careful. You don't want this to get flat right here. Right? Because the height right here is still 2. So that means this should still be pretty steep. Actually, it should be a little steeper than even I drew it here. If you want, you can erase that and make it a little bit more precise. I guess I will. But my point is just make sure you have the same overall shape. But while you're doing that, check in every so often. I only want to be flat at this point and this point. So you have to be careful to make sure you don't flatten out. What shape do I then switch to? My last little interval will be increasing and concave down. Increasing and concave down looks roughly speaking like this. So if I pick it up from here, I can finish up my graph, draw it like this. This right here is a graph of a function g of x that has the derivative g prime of x that goes through the point 0, 0. Maybe that helps you. Maybe there's lots of other ways you can do this, but I think breaking up into these intervals can be helpful. So there's me illustrating that method.